In this video, we're going to be learning about consecutive integer word problems. Consecutive integers are integers that follow in a sequence, each number being one more than the previous number. For example, if we have three consecutive integers and the first integer is 14, then the second integer would have to be 15 since it's one more than that, and the third integer then would have to be 16. 14, 15, 16 are the three consecutive integers. If we want four consecutive integers and the first integer is 7, then the second integer would have to be 8 since it's one more than that, and then the third would have to be 9, and then the fourth would have to be 10. 7, 8, 9, and 10 are four consecutive integers. If we want three consecutive integers and the first integer is x, well then the second integer would have to be x plus 1 because it's one more than the first one, x. And then the third integer would have to be x plus 2 because it's two more than the first. Okay, the first number was 14. We'll call that one x. The second one was 15, x plus 1. And the third one was 16, which was 14, or x plus 2. Okay, so if you're looking at consecutive integers, they're always going to be one more than the previous number. Let's look at our first example of a consecutive integer word problem. Remember, for any word problem that we do, we're going to write a let statement defining any variables that we use. We'll set up our equation algebraically, we'll solve it algebraically, and then we'll state the answer to our question with a short sentence. In our first example, it says that the sum of three consecutive integers is 39. Determine the value of all three integers. Okay, so our three integers are going to have to follow in a pattern. All right, the first one is going to be some unknown value. The second one is going to be one more than that unknown value. And the third one is going to be two more than the first unknown value. So that's going to help us here when we first write our let statements in step one. Let some number be the first consecutive integer. Well, I'm just going to use x as my variable. Let x equal the first integer. All right, if x is my first integer, then my second one has to be one more than that. So let x plus 1 equal the second consecutive integer. And I have three consecutive integers, so let x plus 2 equal the third consecutive integer. All right, since I'm working with three unknown numbers here, I'm going to write three let statements. X is my first integer. One more than that, x plus 1 is my second consecutive integer. And x plus 2 then is my third consecutive integer. So now that I've defined those, let's see if we can set this problem up. It says that the sum of those three consecutive integers is 39. So what I need to do is take these values that I've used for my integers and add them together. So in step 2, when I write down my algebraic equation, my first integer was x. I'm going to have to add that to my second integer, which was x plus 1. And I'm going to have to add all of that to my third integer, which was x plus 2. The sum of three consecutive integers is 39. There's what our equation must look like. The first number plus the second number plus the third number adds up to 39. Let's go ahead and simplify on the left-hand side. X, and x is 3x, plus my constants, 1 plus 2 adds up to 3, equals 39. And now this is just an easy two-step equation for us. We'll start by subtracting 3 so that we can isolate the variable term on the left. When we do that, 3 minus 3 is 0, so 3x is on the left, and on the right, 39 minus 3 is 36. Now we'll divide each side by 3 to figure out what x is, and when we do that, x is going to be equal to 12. And so that was the third thing that I needed to do. And now the last thing I need to do, I need to determine the value of all three of the integers. All right, well, x was my first integer. X, I just found out, was equal to 12. So x equals 12. X plus 1, my second integer, is just one more than that. X plus 1, all I'm going to do is 12 plus 1, which is 13. And then finally, x plus 2 becomes 12 plus 2, which is equal to 14. All right, so if I add these three numbers together, I should end up with 39. Well, 12, 13, and 14, if I add them together, 2 plus 3 is 5, 5 plus 4 is 9, 1, and 1 is 3. I know it works out. So I can say the first integer is 12, the second integer is 13, and the third integer is 14. All right, 12, 13, and 14 have a sum of 39. In our next example, we're told that the sum of the smallest and largest of three consecutive integers is 60. Determine the value of all three integers. Okay, so for this example, our setup is going to be very similar to the first example that we did. We're going to let some variable, let's use n this time, let n equal the first integer. And then since we're dealing with three consecutive integers, we're going to say let n plus 1 equal the second consecutive integer. And then we will say that n plus 2, let n plus 2, n plus 2 is going to be the third consecutive integer. Okay, so I have defined my three integers, my three unknown values in this problem, and now I'm going to set the problem up algebraically. It says that the sum of the smallest and the largest is 60. All right, so the smallest one would have to be n, and then the largest one would have to be n plus 2. The sum of those is 60. So I'm going to write down n, which was my smallest integer, plus my largest, n plus 2. Their sum equals 60. All right, setting up this equation is going to allow me to figure out what the value of every consecutive integer for this problem is. All right, so on the left, we can say n plus n is 2n, and then plus 2 is 60. If we isolate the variable term on the left, we need to subtract 2 on each side, meaning that 2n is going to be 58. And then if we need to find half of 58, well, that means that n is going to be 29. I almost wrote 39 there. N is equal to 29. All right, half of 58 is 29. All right, well, if n is 29, that's my first integer. And my second integer, n plus 1, is 29 plus 1, which is 30. And then my third integer is n plus 2, which is 29 plus 2, which is going to be 31. So let's see if these values satisfy the conditions of the problem. The sum of the smallest, which is 29, and largest, which is 31, has to be 60. Well, 9 plus 1 is 10, carry a 1. 1 and 2 is 3, 3 and 3 is 6. It works here. It works. So I can say the smallest integer is 29. The second integer is 30. And the largest integer of the three, the largest integer, is 31. All right, so again, 29 and 31, the smallest and the largest added up to 60. So my three integers are 29, 30, and 31. Sometimes you'll have a question, and the question is going to ask for consecutive even or consecutive odd integers. Okay, in examples like those, we need to really think about the numbers that we're working with. All right, if we have three consecutive even integers and the first integer is 12, then the second even integer would have to be 14 because 14 is the next even number after 12. The third even integer then would have to be 16. All right, 12, 14, 16 are three consecutive even integers. If we have three consecutive even integers and the first integer is x, all right, for example, up here we can say 12 was x, then the second integer would have to be x plus 2. All right, if we took 12, we would have to add 2 to it to get to 14. The third integer, third even integer, would have to be x plus 4. All right, if x was 12, we would have to take 4 to add to 12 to make it to 16. So x plus 2, and x plus 4 would be our three consecutive even integers. If we have three consecutive odd integers, then the first integer is 23, then the second odd integer would have to be 25, since 25 is the next odd number after 23. The third odd integer, therefore, would have to be 27. So if we have three consecutive odd integers this time, and the first integer is x, which that was what we'll call 23 in this problem, x is 23, then the second odd integer would have to be x plus, well, let's think about that. X is 23. What am I going to have to add to 23 to make it up to 25? Well, I'm going to have to add 2 to 23 to make it to 25. So x plus 2 would be my second odd integer. And my third integer, odd integer, would have to be x plus 4. Again, if x was 23, I would have to add 4 to it to make it up to 27. This gets a little tricky for some people because they're thinking odd numbers. Well, I'm not going to have to add 2 and 3. All right, they think I'm going to have to add, or 2 and 4 rather, I'll have to add 1 and 3. But that's not going to get you to the consecutive odd integers. Don't get tricked by these problems. Consecutive odd integers are always 2 units apart from each other. So if you start at x, you're going to have to add 2 to x to make it to the next odd integer, and you'll have to add 4 to get to the third odd integer. Let's look at a practice problem where we're working with three consecutive even integers. All right, in this problem, find three consecutive even integers whose sum is 18. Let's go ahead and set up our let statements. All right, number one, let x equal the first even integer. All right, if x is my first even integer, then to get to my next even integer, I'm going to have to take x and add 2 to it. So let x plus 2 equal the second even integer. And then to get to my third integer, I'm going to have to add 2 to the second one, which means that I'm going to have to add 4 to the first one. Let x plus 4 equal the third even integer. Now that we've got this set up, let's see if we can make an equation out of it to represent the problem. All right. Find three consecutive even integers whose sum, so I'm going to be adding these up, is 18. So the first even plus the second even, x plus 2, plus the third even, x plus 4, their sum is 18. Let's go ahead and clean up the left-hand side. X plus x plus x is 3x. Plus my constants, 2 plus 4 is 6, equals 18. And now we'll isolate 3x on the left by subtracting 6 from each side. That means that 3x is going to be equal to 12. And then we divide each side by 3, which means that x is equal to 4. And so that's the third thing that we had to do. Now we have to figure out the values of the numbers in our problem. All right, so in this first integer, my first even integer is 4, and I already know I'm off to a good start since 4 is an even number. My second even integer is x plus 2. That becomes 4 plus 2, which is 6. And then my third integer, x plus 4, becomes 4 plus 4, or 8. If I add these three numbers, I should get 18. Well, 4 plus 6 I know is 10. 10 plus 8 is 18, so that works out. So I can say that the first even integer is 4. The second even integer is 6. And the third even integer is 8. All right, 4, 6, and 8 are 3 consecutive even integers who will have a sum of 18. Our next problem tells us that twice the smallest of 3 consecutive odd integers is 7 more than the largest. Determine the value of all 3 integers. Okay, so there's a lot happening here. Let's first realize again, we're talking about 3 consecutive odd integers. So let's set up our let statements here in step number 1. Let's let n equal our first odd integer. Okay, if n is my first odd integer, my second odd integer is going to be 2 away from that. Okay, so my second odd integer, let n plus 2 be that second odd integer. I had to add 2 to get to my next odd integer. And then I'm going to have to add 2 to that. So let n plus 4 be my third odd integer. Okay, so n is my first odd integer, n plus 2 is my second odd integer, n plus 4 is my third odd integer. Let's now use the wording of the problem to set it up algebraically. Step 2, here we go. Twice the smallest, all right, well, my smallest is n, so I'm going to have 2n, all right? Twice the smallest of 3 consecutive odd integers is 7 more than the largest. All right, well, the largest is n plus 4, and 7 more than that means I add 7. Okay, twice the smallest is 7 more than the largest. Let's see now if we can figure out what the value of n is so that we can get the value of every integer in our word problem here. Let's see if we can clean up this right-hand side. 4 plus 7 is 11, so I'm going to have 2n equals n plus 11. And then all I need to do is get my variables on one side. So that's a 1n right there. I'm going to subtract 1n from each side, meaning that n equals 11. And look at that. We've already figured out the value of our variable, n equals 11. So my smallest odd integer up here is 11. My next integer, n plus 2, becomes 11 plus 2, which is 13. And then my third odd integer, n plus 4, becomes 11 plus 4, and that equals 15. Let's see if these numbers work for the conditions of the problem. Twice the smallest, 2 times 11, is 7 more than the largest, and the largest was 15. Well, 2 times 11 is 22, and 7 plus 15 is also 22, so that works out. So now we can say here, all right, that was our third step, our fourth step here, our sentence here. The first odd integer is 11. The second odd integer is 13. And the third odd integer must be 15. 11, 13, and 15 are the 3 odd integers in this problem.